what we'll be talking about now is the explanation of your term project. Okay. So let me just make sure I share the right screen first. What is it? No, not coronavirus. There we go. Okay. So what we're going to be doing today, now we going over to you with the project description of the project you're supposed to be completing towards the end of the year, from now until the end of the year. The purpose of the project is to actually create a piece of software. Yes, you're gonna have to program something. Okay, you can use Java. I prefer if you use Java, but you can use some other object-oriented programming language if you're comfortable with that, or Python, which is also object-oriented, of course. But I'm leaving the choice up to you, although the actual project description says Java, but I'm leaving the description up to you. The objective of that piece of software is a software I can give it a graph, okay, and it can do the data flow coverage for that graph, okay, and basically I give it a graph and I ask it, say, what are the all depths test requirements? What are the all depths? Sorry, what are the test requirements for? I flipped that. Sorry. What are all the test requirements for the all depths coverage? What are all the test requirements for the all users coverage? What are all the test requirements for all the DU path coverage? Okay. Now, I don't want any graphical user interface. Okay. Maybe we'll leave that to some later date for some later group to work on that. So I don't want that. Keep it simple, okay? What you're gonna be doing is you're gonna be constructing that graph as a data structure, okay? Nodes, you can represent objects and they're linked with each other with some sort of edge. So if you remember your data structures course, this is a bit of that, quite a bit of that, okay? And you're probably wondering one day, like, when am I ever gonna use this data structure stuff? Well, this is one case you're gonna be using, and you're gonna be using it before you even graduate. So what I want you to do is through the just the regular command line prompt, whether it's using the DOS prompt or the an Apple version, a Unix version of it, a shell, should I say, you get to ask, like, what are the nodes that are there? What are the edges between the nodes? So this is one phase of the software, which is the building of the actual graph. And then you ask, which test requirements do you want? Do you want test requirements for all depths? Test requirements for all users? I wrote all users, but that's actually all users. And finally, if you want, you ask the user if they want the test requirements for all DU paths. Okay. And then it just produced them on the command prompt line right there. So like I said, immediately I'm actually telling you, it's kind of like the assignments that you were doing in SC100, where you don't actually have a graphical user interface. You don't really need an interface, a graphical interface, in order to achieve the purpose and the objective of the software system. So simply you can just rely on the command line to construct your graph and to execute the functionality required to produce the test requirements for the different data flow coverage criteria. Now, I'm going to skip this part in the middle now for just a moment, the project operational guidelines. I'm going to go down to the project implementation. Basically, we have one date, and that date is December 9th. You work on your own pace, all right? But just make sure that come December 9th, this is Judgment Day. And what we'll do is, in the class, we're going to get everybody that have created that software to turn on their software and get it running. And then what I'll be doing in the class is I'm going to be giving you different test cases. Okay, and the test cases are different graphs for you to draw. Not to draw, I mean to use to check for the coverage criteria. Okay, so gonna begin easy, like this is test number one, test number two, test number three, and as we go through the different tests, the graph that we're dealing with becomes more complicated. And then each time we do one of these tests, I walk around, see which one of your software have passed and which one of your software has failed. Obviously, your entire mark is not just based on you passing or failing the tests. All right, you might not even pass a single test, but you've actually put in a lot of effort into creating the software. Um, so so that is worth a lot of marks too. Okay, obviously the test is worth marks, and that's probably going to what's end up differentiating one group from the next one. Okay, so this is how the project is going to be tested. I want you going to be submitting your source code at the end, maybe a bit of a report on how to use that software. Okay, like a sort of like a user manual. Now, given the class size, there's going to be three groups, one female and two males. The female group is rather obvious. Now, for the two males, we have 5 males in this group, so I want the groups to be split down into two groups, one of which is going to be 2 members, and the other one is going to be 3 members. You choose yourselves to divide upon yourselves who you want to have as group members, right? And once you stick with it, you're going to stick with it to the rest of the year. I would like to hear your selections finalized before the end of October 24th. So by next Sunday, because you need to get started right away with the project. You can't spend so much time deciding, are you going to be in my group or I'm going to be in your group and so on. Okay. And that's it basically. Come December 9th, you're going to be demonstrating that your software product is working correctly through the test cases that I'm going to give you in that class. And then you submit your source code along with a final report, which is going to be acting more of as a user manual. All right, so now questions. Does anyone have any questions about the project description and what you're supposed to do, the operational guidelines? Hello? If it's clear, you can just write down that it was clear. Okay, thank you, Abdurrahman. And as for the rest, we got Banan, Fad, Ibrahim, Sadoun. Is it clear what I'm asking for you to do for this project? Okay, thank you, Sadoun. Banan, is it clear? Fahd and Ibrahim, can you please respond? Okay, thank you, Fahd. All right, so it looks like maybe Ibrahim or Banana stepped away from the computer at the moment, but yeah. So if you have any questions that arise, which is normal, go ahead. My advice: get started early. Don't wait to have the completion of the implementation on December 8th, because this happened in the previous year, last year actually specifically. I ended up giving that group a first test case, and that first test case failed right on the spot. Okay, so they ended up failing all the remaining test cases. Okay, so what you want to do is you want to actually have completed your software development at least maybe 2 weeks, so that you can have a chance to test it, you know, create your own graphs and make sure you run your own tests. All right. And then visually, then I start to give you the graphs as a visual representation, which you input into your software and run those. Okay. So like I said, don't leave the implementation to the end. You want to have the implementation done at least a week before December 9th, so you can begin testing it yourself with trivial graphs and then intermediate graphs and then more complicated graphs. Okay. It is a big project. It sounds simple, but it is a big project. So don't start coding December 8th. You're not going to be done. Okay. And you're not going to be ready in time. All right. I might come somewhere in the middle and ask to see a progress, kind of like to force you to do something before December 9th to see your progress. And I believe I did that with my group last year, and I think it was a good idea. All right. So we're gonna pause here. Pause the recording.